variable. No matter what happens, I always cover it.
All right, so I'm gonna go over any question you have. I know some people says I didn't do good on this part. This is a big part of the test to figure out from where to where. Okay, so I am gonna help you whatever you need. So the first one is -2. The second one is -5 minus pi. The third one is, hold on a second. The third one is 7.5. And the fourth one is gonna be 22 minus pi. 6.5, 2, and 2.5 plus pi, and negative 0.5. Let me know which one you have question on. I'll answer all the questions. Min, you want to ask me a question?
Yeah, how do you do B?
How do you do B? That's a great question. So for me, like I always pay attention to the boundaries. This boundary is 7, this is a 4. I don't like that orientation. Why I don't like orientation? Because I rather have one set of orientation. I just have to know if the graph is above, it's positive. The graph is below, it's negative. If I have this, it's going to be everything reverse. So I rather just write it again to write it like this, which is I'm going to write it from 7 to 4. I'm going to write it instead of 7 to 4. I'm going to put a negative sign in front, become 4 to 7. And then 4 to 7, all I got to do is go to 4 here. So that is 4 right here. And then if you go to 4 to 7, that's going to be just count up the areas. So this is a 1 plus 4. This is a quarter circle with 2. So that's going to be 2 times 2 times pi. So it's 4 pi. But divided by 4 is pi. So it'll be 5 plus pi. Now remember, this is 5 plus pi, but don't forget there's a negative sign in front. So it'll be negative 5 minus pi. So the answer is like this. Any signs wrong is wrong on the test. So you have to be very cautious of this kind of stuff. It's easy point, but it's very hard to get it correct. So yes.
Do we divide it by 4 because it's like one positive circle?
Exactly.
So if it was like 1/2 a circle, we divide it by 2, right?
Exactly.
Why?
Because what kind of circle is this?
It's like a quarter of a circle.
Yep.
So you divide by 4 and then you well, I thought that was no one. Yeah.
Okay, next question. Malin, if you have a question, ask. Catherine, if you have a question, ask. Elaine, question, ask. Jack, something you are confused, just ask.
So over the one that goes from -3 to 4.
-3 to 4. Okay, sure. -3 to 4. Okay, so this one here. Okay, -3 to 4. Basically, I'm going to take account into from -3 to 4 right here. Now, I can just count up all the positive area. The positive area here is going to give you, I will say, probably, this is not 2. This is going to be 3.5 for this particular part. 3.5 times 3 times 1/2. So that is going to be 9 over 4. Is that okay? So this part is 9 over 4. Now this part is going to give you negative 1/2. Why? Because that base is 1, the height is 2. But it's a negative sign. This one is about 1.5 times 1. So it's 3 over 2 times 1. So it'll be 3 over 4. Why is 3 over 4? You have base is 1.5, the height is 1, and times 1/2. Are we okay so far? All the way to 4 is going to be 3 times 2 times 1/2. So that's equal to -3 because below x-axis. So you're just going to add up 9 over 4 minus half plus 3 over 4 minus 3. Hopefully we got the right answer here. This 2 combined together is going to give you 3. And minus half minus 3. So 3 cancel out. It's going to be -1/2. So that is -0.5. See here, -0.5. I put it. I'll add up all the positive part, and I'll subtract all the negative. I'll subtract all the below the axis area. Some people have a question about absolute value. What does absolute value do? Makes all the negative part graph is gonna be positive. So let's just say if I am interested about absolute value part, basically, this part of the graph is gonna be facing up, and this part of the graph is like this. So this one is gonna be 3. And here is gonna be 1.5. No, actually it's 0.75. And this one is 0.5. And this one's 9/4. If you add up all together, it should equal to 6.5. And that's the way to think about it.
So like for this one, we don't like subtract anything. Like it's just how we do it normally, but instead of like subtracting, if it's below, we just add it.
Well, you gotta think about it. Negative part of the graph is gonna reflect to become positive.
But the positive isn't reflected.
The positive doesn't, because the square root of positive number is still a positive number. Square root of a absolute value of negative number is equal positive. Absolute value of positive number stays positive. So only negative part of the graph reflecting across x-axis.
But like in general, like you know how normally when we do it, like we subtract if it's below the x-axis.
Yeah, but just think about it. The negative part of the graph reflect. So you're adding that.
Yeah. So instead of subtracting, we just add it.
Yes. Okay. But don't memorize it. But understand the graph.
You're basically looking at the area.
Madeline, do you have any question?
I'm really saying.
I have a question. So if you have, it's not like this a little bit, but like if I have like, let's say I have a boundary like 1 to 3 and f of x, but if I did f of x, but in the parentheses I said +1,
Yeah.
would I have minus on the boundary?
Oh, instead of graph like this.
Yeah.
Okay, so let's just say, let's do this. F of x plus 1, this whole graph is shift left 1 unit. So let's just say between 0 to 1. Okay.
Yeah.
If I do that between 0 to 1, now this part is gonna shift right. It's gonna be like this, right? So that's gonna be -half because it becomes below x-axis. So the whole graph shift left 1. Great questions. Because that whole graph shift left 1. Now, what I like about this question C. C is good because you just break up to integral and you can actually do definite integral here. Definite integral of 2x just gonna be x squared, and then just plus 9. 9 minus 1/2, you're done. Does that make sense? Break up to 2 parts. Same thing of D, you break up to 2 parts. Am I confusing you guys? Men? No? Break up to 2 parts. If you have 2 parts, break up to 2 parts. Do integrate on that separate things, because that 2 is very easy to integrable. 2x is very easy to integrable. It's not a big deal. Any other question you need to know on the test? Test is moving to Friday, just because I want to cover one difficult concept.
Because we're learning more content.
Yeah. Bro, if you pay attention on homework, it's always similar to homework. I want to review something that's very important, which is mean value theorem for integral. No, mean value theorem for derivative. And why did I do mean value theorem for derivative, although you learned it before? I will say at least 4 points on AP exam, 4 out of 108 is based on mean value theorem. And you have to understand it. If you don't understand it, it's take out the 4 point. Remember, you want to get 3 on AP exam, or you want to get a 5 on AP exam, you need those 4 points. You only need 42 points to get a 3. A 7th grader can get a 3. I promise you. I have an 8th grader student got a 5 on AP exam before. But he didn't even do homework. No, he was not cheating. He was actually smart. Okay, so let's talk about mean value theorem for derivative. A, the condition. The condition says f must be what? Continuous between a comma b bracket. It cannot be an open circle, okay? B, f must be differentiable between parenthesis a and b. Okay, that is the second one. The third one is the result is there is a C number or numbers C where f prime of C is equal to fb minus f of a over b minus a. So for me, this is known as the secant slope. This is the tangent slope. Also, one more thing I need you to know. This is also known as the average rate of change. Do not get confused on AP exam between average rate of change and average value. Rate of change is the slope. Average value is the integral. Let's say that again. Average rate of change is the slope. It's algebra 1. y2 minus y1 over x2 minus x1. This one is called instantaneous rate of change. This is a very, very important. At least 4 points on AP exam. If you don't understand this part, ask me any question. I will explain to you. Sometimes they can just even ask you average rate of change of this function. Then just fb minus fa over b minus a. They can ask you instantaneous rate of change. Just take a derivative. They can ask you mean value theorem, just going to be both equal to each other. They can ask you secant line, tangent line. There's so many variety of the question can come from mean value theorem for derivative. Not only that, you can see the graph that is going to be from A to B, and you have 2 points like this, and you have some type of graph like this. Okay, some type of graph. This is f of x. This is called a secant slope. This is going to be secant slope. So what mean value theorem says, secant slope is equal to tangent slope. Somewhere around like C here and C here, this has the same slope of this. The red line has the same slope. So this is a tangent line. And this is a tangent line. So they're just asking where the C value have the same slope as a secant line. This should not be anything new. This is all the old stuff that you're supposed to know on the previous test that's going to be on AP exam. Now, for me, I have problem people doesn't understand what does mean by average rate of change. Average rate of change is just FB minus FA over V minus A. That's algebra 1. Now, average value, what we talked about yesterday, is not average rate of change. Average value is 1 over b minus a over a b of f of x dx. That's average value, also known as the average height of the area of a rectangle equal to area under the curve. Now, what is mean value theorem for integral? So mean value theorem for integral. What the hell is the mean value theorem for integral? Well, mean value theorem for integral is super easy. It's just like average value. It's just like you find out which x value between a and b that give you the average value. That's pretty much it. I'm gonna say that again. You find out which x value, in this case it could be c value, where that c value can give you a height, which is the average height. So you find out the x that give you that value. That's pretty much it. Okay, so I'm gonna say that again. I'm gonna give you a book definition, it's better. They say if f is continuous, so they only have to be continuous. Does not have to be differentiable on closed interval between a comma b. There exists a number c, could be number or numbers, in closed interval where integration of a to b of f of x dx is equal to f of c times b minus a. Do you see any difference between this and the average value? What would be the only difference?
Or you're just setting it equal to FOC.
You just said equal to f of c. Yeah. You can you just divide by both sides by b minus a? Right? If you divide by both sides by b minus a, you're gonna get 1 over b minus a.
What did you write there? There exists a.
There's a number in a closed interval where integration by a of b of f of x dx equal to f of c. So this one is gonna be x dx is equal to f of c. You are looking for c this time. Why are you looking for c? That c is gonna give you the average value. Does that make sense? The particular x value is gonna give you the average value. Now you're gonna be like, I don't know what you're talking about. This guy's on crack. So 3x squared, I'm on crack sometimes. Not all the time.
Sharing is caring, Mr. Ye.
I'm on math.
Yes.
I just keep saying that because you're right.
Math.
I know.
Sure, I guess. I don't know. It's confusing. Oh my god.
Now imagine that I have this area. We talked about this yesterday. At 1, I'm gonna get 1 comma 1. At 4, I'm gonna get something like 40. And I'm gonna get some type of graph like this. This has some type of area, like a red area. We don't know what the area is, but the red area, I can take an integral of 3x squared minus 2x dx between 1 to 4, right? Now I'm gonna say there's a brown 1 over 4 minus 1. What's 1 more 4 minus 1? That means at sometimes at this point here, oops, my bad. Sometimes here that I'm gonna get the height here, and this height is 16. Why? Because you take out an area divided by 3, that's equal to 16. The 16 is the average rate of change. Now instead of this part, I'm gonna say it's equal to f of c. So this is a 1 over 3. Brown is 1 over 3. And the area is 48. I did a calculation. Is equal to f of c. This part is the blue part, which is what we're trying to find what the f of c is. This is 16. Is equal to f of c. Guess what? What's the f of x? f of x is 3c squared minus 2c is equal to 16. How do you solve for c?
Quadratic.
Do not factor out c.
You subtract 16
Subtract the 16.
and then do box method.
Do box method, that's good. So that is gonna give you 3c squared, 16 minus 2c. And that's gonna give you 3c and c, 2 and 8. And that's gonna give you negative here. So it'll be 3c minus 8 times c plus 2. C equal to 8 over 3, which is the answer. C equal to negative 2 is not an answer because it's outside the interval. So that means at this value here, if we drop straight down, this is going to give you 8 over 3. So which x value is going to give me the average value? That is the mean value theorem for integral. That's it. Yes. Sure.
Mr. So at 8 over 3 and y value 16.
Yeah.
Okay.
And that 16 is going to give you the average height of the rectangle. It's give you exactly the same areas under the curve.
Okay.
It's not hard. It's just talking about average value. Which x value could be the average value?
We go back to the original equation.
Okay, I think I'm fine. See one fast. Yeah, it's up. You know, one.
Yeah, that's c value is actually one of the-
You just did these so that way you can afford. And that would be like,
Now I'm going to talk about how much time I have.
You've got
I don't know.
13 more minutes.
13 more minutes.
Yeah.
Okay, good.
30 seconds.
So that's okay. This is just same thing as yesterday. Average value. You find out which x value is gonna give you the average value. That's pretty much it. Not a big deal. Not like something strenuous or something new. Now this is something new though. Interview. That's review of yesterday or 2 days before. If I have integrate of this, integrate of this between a to b, we know this is equal to f of b minus f of a. This is known as a fundamental theorem of calculus.
Yeah.
Now, fundamental theorem of calculus, it's great. But I give you an analogy. If you take a hammer and nail and you hammer into the wall, right? And it's gonna be a nail inside, right? Now, it's possible for me to take it out.
Yeah.
Use the reverse part of the hammer, right? That part you can pull it out. Now, if you're a good handyman, unlike me, I will probably like smash my fingers when I try to nail something or put a nail in the wall. Done that before. Not very smart. So I told my wife I can never be a handyman. Sorry, I'm gonna hire a handyman to do the job. I'm gonna
You get
teach.
the money.
Huh?
You get the money from tutoring.
Yeah,
You get-
I'll get paid from tutoring. I'll pay someone else for handyman because they doing their specialty. I do my specialty. But
What's
my
the-
wife doesn't understand that. My wife says, "No, you should be able to do anything. You're a man. What kind of man are you?"
most
What are we
about
talking
my
about?
dad.
Wait, how much? What's your hourly rate for tutoring again?
A lot.
Isn't it 75?
No,
I thought it was like 200, right? 150.
150. Yeah.
Oh my.
Per
Wait.
hour?
That's like serious.
Like,
How do you
Huh?
Like algebra kids?
There are people that's gonna pay me.
the same? Like, so if I pay you $150 for 2 hours, will you come to my guitar concert? Jesus Christ.
Wow.
Well, great. You need to pay him 300. Yeah, exactly. That's what I meant. Like, well,
All right. So what is the second one? The second one is taking the derivative. That's taking derivative d to the dx of something. Well, what is that something? 0 to the x of f of x dx. Now this is called fundamental theorem of calculus 2. What do you think it is?
Is it f of x?
Exactly.
plus b?
It's just f of x. There's no plus c.
Oh.
So this is called fundamental
Yeah, because you did a derivative.
Looks like cancel out, right?
Well, it's technically not cancel out. We're talking about this is a perfect situation. This is a handyman doing a job, which is your test question is never a handyman situation. Your situation is gonna be a little bit different. When you take out, your nail is completely crooked. That's what happened with your test question. Now I'm gonna show you what happened here. Slow motion of what happened here instead of just say, hey, this is this way. So first of all, I'm going to do fundamental theorem of calculus part 1. So that's equal to what? D to the dx. What's integration of lowercase f? Capital F minus capital F of 0. Does that make sense? Now, if I take a derivative of this, it's going to be what? Small f of x. Now, be careful, be careful. I also had to take a derivative inside. It's called chain rule. So that is going to be 1 minus f of 0 times 0. Now this happened to cross it out, f of x. And that's why it's equal to f of x. This is a slow motion that happened. Now, why is chain rule impacted? I remember this question. Like I say, I remember this question from a couple years back. I have a girl named Sarah Godwin. She went to University of Chicago for a ride. She was very smart. She always struggled in math. But so when she was in University of Chicago, she sent me a text. She's like, hey, Mr. Ye, I need you to help me solve this problem. This is the final exam tomorrow. And I was like, you send me at 11 o'clock at night? And I said, okay, fine. So this is the question. Was sine of x and the cosine of x? It's a beautiful question, by the way. And it was d to the dx. Okay, it's taking derivative of the function. What is that function? The function is going to be like 1 minus t squared dt. You like, okay.
Oh, but it's x and t.
Yeah, but that's okay. That's okay. That's not a big deal. There are two different color code, and you say, okay, I'm gonna teach you how to do it, but I don't know how to take an integration square root of 1 minus t squared. I honestly don't know how to do it. I don't know how to take integration. And honestly, I don't give a shit if I know how to take integration. I'm gonna assume something. Why do we assume?
Good. Assume.
I'm gonna assume that's g of t. Why do I assume? Because I don't care about what kind of function it is. If I integrate it and I take a derivative, I'm gonna go back to the nail state, right? It doesn't matter. It's a nail. If I hammer it in, I take it out, it's still a damn nail. It might be crooked, but it's still a nail. Is that okay? So what we're gonna do is we're gonna integrate this. We are assuming this. Where's Simon? Every time I look at you, I was just missing Simon.
Okay. Is there something else funny?
All right, so I integrate this. What am I gonna get? G of what? Sine of x, right? Minus g of cosine of x. Because if I integrate the lowercase, am I gonna get the uppercase? Is that okay? Now I'm gonna take a derivative of this function. Did I say I don't really care about what that function is because I'm gonna take integral and I'm gonna take it following with derivative. So I don't really care. So I just assume that's a function. And we're gonna integrate that function, becomes capital G, and then we're gonna take a derivative. It's gonna be lowercase of g. But the problem is this. I have to take a derivative to the inside. Because the chain rule. So be cosine of x. Does that make sense? Minus g of cosine of x times negative sine of x. Is that okay? And you're like, oh, okay. Now, this is the hardest part, but it's actually easy. This means I'm going to plug in the sine of x into the t. So it'll be square root of 1 minus sine square of x.
And that's cosine squared of x with cosine, right?
Yep, so it'll be 1 minus cosine square of x times negative sine of x. That becomes square root of cosine square of x plus sine square of x times sine of x. Guess what? That's cosine of x times cosine of x. Sine of x times sine of x.
And that
With 1.
Yep.
no. Yes.
So the answer is 1. And this was this girl's homework or final exam question. She sent it to me. I was like, oh, this looks like a really, really cool question. The answer is beautiful. The answer is 1. I never get an answer is equal to 1. Usually it's some type of function, but in this case, the answer is 1. Usually you're going to get some type of function, by the way. Now, this is going to be your hardest question on your test on Friday.
What?
Yeah.
Oh, okay. I forgot the basket. I forgot the basket.
Oh. Good night.
It's not my house. Would you be able to do it with like secant? That's actually cute.
You can do a different function. Now, not all the time it's going to get equal to 1. Sometimes, most of the time, it's going to probably end up to be some type of equation. Yes. Shh. Negative times negative is equal to positive. And that was that question that she sent me, and I thought it was a really good question, so I decided to help her because I was interested what is the result, and then so I just helped her. She does like, some cool stuff. She's very ratchet and smart at the same time.
Ratchet is great.
But they pay you $50.
Is it just
They
a
pay you
video on the stream
$50
entire
per
time?
hour. Okay, I'll be there.
Do you have $300 to give?
No, I don't. No, here's the thing. I get them to come and then I tell them they don't have the money, but they might as well stay since they're already there.
Just on camera.
Who's this guy saying hi?
Like,
Wait, what's the name?
No, yeah.
It's Surun.
It might be Sean.
Just some Indian girl.
Gorla.
I have no idea how to pronounce her name.
Chandra.
Oh, she's not.
Chandra. I've never heard of this.
But Josh, you should know how to pronounce this name.
Can't spell either.
You cannot pronounce your own language.
It's Surun Chandra.
How to spell her name?
You're good.
SRUJANCHANDRA.
How to say her name?
Surun Chandra.
Pigeon Changda.
Surun Chandra.
What did they Google Translate?
Yeah, you really.
That's a long name. And then you had the white name in the back.
Gorla.
No,
Like this close.
literally
Not far.
it's
Just say like, just sign in and say who are you. Don't be afraid.
Sure. I'll sign in the chat. I don't know how to do that. I've done it before, but
Open in my browser.
let's have a conversation with her. My only viewer. Hi, Gloria.
no.
It's Gorla.
Oh, what?
It's with an L. It's
Gloria. No, I pronounced it right.
No, it's not Gloria. It's Gorla.
No, R. That's R, right? Oh, Gorla?
It's Gorla.
Okay.
I need to see how much time I need.
Is there something funny? Is there something funny?
No, I just thinking the question that you was talking about.
Oh yeah. Are you live still?
Yeah, I'm talking to this person that's on the live.
He got me.
What?
I don't know. I don't got it.
Ronnie, my God, she's not
I won't be. I probably won't come until like 5 o'clock.
Ah.
I'm always here, bro. Don't play with me.
It looks like if a kindergartner.
Kelly, what's your comment about his haircut?
I already saw it yesterday.
Yeah, I know.
It's.
I say it looked like umbrella. It's like small
I
umbrella.
laughed
bro.
when he showed when he showed me, but it's okay. It's just more clean. I feel like even though it's.
I like the spiking part, but I don't know about the umbrella.
Okay, stop doing that, bro. You got Edgar.
It's not that bad.
Bro, I walked in the class and got playing like
It's gonna go wrong.
You can come pick it up on my podcast.
Yeah, I do, man.
Sorry.
Don't laugh.
You can come pick it up on my